Hello everyone, welcome back to my channel. I'm Sanjana from Sri Venkateshwara College of Engineering. In this video, let us see stack and stack operations. In this video, let us see introduction to stacks, stack operations, implementation of stacks, application of stacks, and then conclusion. In this video, let us see introduction to stacks. Stacks in data structure is a linear type of data structures that follows the LIFO, last in first out principle, and allows insertion and deletion operations from one end of the stack data structure that is top. Elements are added using push and removed using pop. Understanding stack operations like display, overflow, and underflow is crucial efficient programming. Let us see the operations of stack. Push operation, pop operation, display operation, overflow and underflow operation. Now let us see what is push operation. The push operation is used to add an element to the top of the stack. When you push an element onto the stack, it becomes the new top element. The push operation increases the size of the stack by 1. The newly pushed element is placed on top of all the existing elements, pushing them down. After the push operation, the newly added elements can be accessed or removed using the pop operation. The push operation is also sometimes called insert or enqueue in other data structures. Now let us see what is pop operation. The pop operation is used to remove the top elements from the stack. When you perform a pop operation, the top element is removed from the stack. The size of the stack decreases by 1 after the pop operation. The elements that is popped in no longer accessible from the stack. The element below the pop elements becomes the new top element. The pop operation is often used to retrieve and remove the most recently added elements from the stack. It is important to check if the stack is empty before performing a pop operation to avoid any errors. Now let us see what is display operation. The display operation is used to view the elements in the stack without modifying or removing them. When you perform a display operation, you can see the elements in the stack in the order they were added. The display operations does not change the size and content of the stack. It allows you to observe the current state of the stack and understand its contents. The display operation is helpful for debugging and verifying the correctness of the stack implementation. You can display the elements of the stack from top to bottom or from bottom to top depending on your performance or the requirement of your program. Let us see what is overflow operation. Overflow occurs when you try to push an element onto a stack that is already full. It happens when the stack's capability is reached and there is no more space to add new elements. When an overflow occurs, it typically results in an error or an exception indicating that the stack is full. To prevent overflow, it's important to check if the stack is already full before performing a push operation. That you can see the example below. Now let us see what is underflow operation. Underflow occurs when you try to pop an element from an empty stack. It happens when there are no elements in the stack to remove. When an underflow occurs, it typically results in an error or an exception, indicating that the stack is empty. To prevent underflow, it's important to check if the stack is empty before performing a pop operation. That you can see in the example. Now let us see the implementation of the stacks. Create. The create stack function can be implemented as a 1D array. The example is given below. And let us see is full. Check for overflow. In order to perform a push operation, we need to check whether the stack is completely filled with elements or not. That is, We can see the example below. Now let us see push. Insert an element into the stack. First, check whether sufficient space is available in stack. If available, then increment the value of top by 1 and then insert the item into stack. The example is given below. Let us see the fourth implementation is empty. Before we delete an item from the stack, we must need to check whether there is any elements in the stack. You can see the example below. Now let us see the fifth implementation, pop. To delete an item from the stack, the pop implementation is used. You can see the example below. Sixth implementation, display. Print the contents of the stack by using display. You can see the example in the below. Now let us see the applications of the stack. Function call stack. Used in programming language to manage function calls and local variables. Expression evaluation. Used to evaluate arithmetic expression such as infix, postfix, and prefix. Used in recursion. Used in conversion of expression. Finally, let us see the conclusion. A stack is a fundamental data structure that follows the last in first out principle. It is widely used in computer science for managing function calls, expression, evaluation, and various applications. The key operations on a stack include push or pop. Stack plays a crucial role in algorithm and programming, providing efficient solutions for various problems. Understanding how stack works is essential for any programmer. Thank you. Please like, share, and subscribe.